David and colleagues have tasked me with something that's a healthy challenge, which is figure out how we sort of get from today to tomorrow. And the tricky bit is that today is extremely noisy, as I think everyone here is well aware. But there are signals that we can parse through longer dated data sets in some cases, some things that y'all might not have seen all of the time, that also give us an indication about where we might be going. And so I'll start with this one, because it's the longest dated one I could find, which is our human emissions. You all probably are aware of this, but it's always worth taking a look at it for the specific shape. We emit about 35 billion tons a year. Almost all of that comes from oil, coal, gas. A little bit of stuff comes from cement, comes from flaring. The important thing about it is that if there is a change in this pattern, you can see that it is very small indeed. Look closely and you can see things such as Great Depressions. You can see world wars. You can see oil price shocks. You can also see something that I'll keep returning to, which is the changing nature of who is emitting what over time. But this is how we got to where we are right now, let's say. CO2 parts per million. It's the highest it's been in 800,000 years. You cannot miss the human element within that. But one of the things that we're finding as well is these changes, not just changes in temperature, not just changes in CO2, but more relevant things right down at Earth level, literally at Earth level. I was flying over Lake Mead this morning, and you might have noticed that it's a little lower than it usually is. This is because we have two things happening at once that are sort of hard to square but are important to think of, which is atmospheric humidity is generally higher. That's because warmer air holds more moisture. That's what gives you things like crazy flooding events. But we also have a drier surface, which is what gives us droughts. And actually combine the two of those things and you have really bad outcome, which is you might be getting the precipitation that you were looking for, but it's not happening exactly when you were hoping for it. And then we're at this, which is like the thing that drives all of this more proximately is our primary energy consumption. This is what we use to do work. It is more or less tripled, close to maybe even quadrupled since the middle of the 1960s when BP began its data. Same pattern again, just as you see in the emissions, there's almost no interruption. Take a look at primary energy, and it is very, very hard in this timeline to see anything with a major, major disruption. In primary energy terms, you can barely see oil crises. You can see some flattening of activity in the 1980s. You can see the global financial crisis only barely. The one thing you can see is COVID. But what we've managed to do as humans is pretty much keep this going with a tight coupling. But one of the things I'll keep talking about in here is that is changing over time. And one of the ways it's changing is this, which is that in all of our lifetimes, the components of that primary energy has shifted growth-wise and volume-wise entirely to countries outside of the OECD. So there's a lot going on in this one. But what I think is most important about it is that in 2007, which is the year that primary energy consumption in the OECD peaked, is also the same year that non-OECD countries surpassed it. Since 2001, when China joined the World Trade Organization, emissions from countries outside the OECD, so not just China, but also India, Southeast Asia, have more than doubled. And emissions in the OECD are actually slightly down in that same interval of time. So if you think about this as a global challenge, it actually has two very, very different vectors to it. And it's worth remembering that in terms of what the addressable market is for sort of bending that curve or changing the nature of what our primary energy supply is going to be. This is one that I get yelled at a lot for, but again, it's BP's data, and it's simply true that we have something that is as close to an exponential curve as you could possibly get when you look at it in the data, and that is the growth of wind and solar, which steadily over time is eating up about 1% of global power generation per year. And it's doubling as a percentage of global power generation every 3-4 years at the moment. And it is also at the point where it is past what was the previous exponential growth curve in electricity supply, which was nuclear in the 1970s and the 1980s. And is just on a path where if you carry this forward, it begins to eat its way into any number of other systems. We still have a growing top line, but we're already at the point where in some economies, which I'll show in a moment, this is beginning to erode. Where there is no growing top line, then you have to have these technologies find a way. And much like Jeff Goldblum would say in Jurassic Park, renewables find a way. Like they tend to be at a point where they are priced, and they tend to be at a point where they're advantageous enough to continue moving their way into the power mix. Where? Well, this is probably a recurring theme, but I can just give you a brief look at it. We've got three big markets, really, the US, Europe, and China. Not only did China pass Europe last year, China's incremental new renewable power generation was slightly more than the UK's entire power consumption last year. So a little bit under 300 terawatt hours of additional clean energy generation added in China last year. And the UK is about 280, 285. Bigger than Australia as well, for reference. So, what's interesting here is you have markets that are both big and growing and really don't have a headwind to them yet from a policy perspective, in particular in China, or a capital markets perspective. Lots of things could happen to change these patterns, but they're fairly smooth, they're fairly consistent, especially when you aggregate them. But this is something that I think is also very important, because if you look at that very scary looking chart of primary energy consumption in the OECD and our total emissions, they are up and up. But if we dig into the math a little bit, it is worth noting that actually we have possibly hit the peak in per capita emissions globally. And that happened about 12 years ago. About 8 years ago in 2012. And again, this is a thing where you can look in and you can see events very clearly here on a per capita basis. You can see the beginning of World War I, you can see the Great Depression, you can see the end of World War II, you can even see miners' strikes in the UK in 1920s. But what we see here is both this giant ramp again starting in the early 2000s. This is China entering the WTO. But since then, you're seeing that erosion of the top line. You're seeing renewables in particular, and to some extent also the rise of natural gas and power mixes beginning to erode the total amount of CO2 emissions per capita. So this is a multifunction output here. Population growth, emissions growth. But it's actually very interesting that we are potentially past something here. And it's not just a COVID thing. It's actually fairly durable. Also, we've had another big rotation, which is jobs. The IEA has this very helpful data out recently that clean energy jobs are 56% of all of the jobs in energy as of 2022. They've always been actually relatively high in recent history as a percentage of total jobs, but they are the biggest part now. And again, they are the growth vector within energy sector employment. And then there's the money. I'm kind of like working us further and further towards the future here, but this is work that my colleagues have tracked for a very long time. For my sins, I had to help arduously piece this stuff all together from press releases and banker phone calls way back when. But we're now at the point where it's a little bit under $800 billion a year worth of what we would call energy transition investment. And it's another thing I'm going to return to, but it's important to note that it's, again, fairly robust. It doesn't actually seem to follow the same economic patterns as other kind of fixed asset investments. You'll notice again that there is barely any blip in the global financial crisis, just a tiny, tiny little bit. The things that change renewable deployment tend to be actually the falling cost of hardware more than the lack of build. So there's a good thing involved in renewables here, which is that as you deploy more things at lower cost for the same dollars, you're doing more. You can also see that the new vector here really is what's happening in the world of transportation and to some extent the world of energy storage. So in very little time, if we think about the world's vehicle fleet as investment, not as durable as a turbine, but more durable, let's say, than consumer goods. And then we're starting to add on the order of about $300 billion a year worth of new hardware that, from an energy management perspective, begins to be very, very interesting. And then there's a little bit of other stuff, and I'll get to that in a bit. And then something else very important is that in the last 15 years, we really have seen a massive rotation on the total installed capacity rotation. Again, capacity is not generation. We're all aware of that, I think, in this room. But if you look at it from a position of intention, what it is that the world wants to be building, 11% of what got built from the global power sector in 2007 was wind and solar. It was 75% last year. It was 50% for solar alone. So, this is a trend that we would expect to keep on going. Obviously, there is, in the early days of this, quite a bit of impetus coming from stimulus and coming from public policy. It is now driven somewhat by that, but often by simply the economics of deploying these technologies in their relevant markets. And what goes underneath that, of course, is the cost of the energy itself. So we've been running a levelized cost of electricity analysis for quite some time. The important thing out of this is both that wind and solar are the lowest cost of the new builds that you could do in almost any market in the world. Not everywhere, but on the global benchmark basis, they are the lowest. Also important is that they are pretty much the same. So from an economic perspective alone, not necessarily from a grid operations perspective, you will find that people are indifferent on that marginal unit based on what they can build economically in a market. But two other things here. First is that, thank you, because of rising fuel costs, you have increasing cost of energy for coal and gas-fired power, as well as, of course, rising CapEx costs and rising financing costs. The CapEx and finance costs impact the renewables as well, but the interesting thing is that even as renewable prices have ticked up in the last couple of months, as BNEF calculates it, the delta between renewable and fossil has never been greater. And in the case of wind and solar, the discount to gas-fired power has never been greater on a global basis. And then there's batteries. I don't put the battery bit in that other chart simply because it looks like a falling rocket if you do, and it makes it very, very hard to see. It's like when we used to run the solar chart back to the year 2005. But about almost 90% down on a CapEx basis for a lithium-ion storage battery, and down by a factor of about 5.5 in terms of the 4 hours of storage. Very important is that that price point, around $150 a megawatt hour, is directly competing with any number of quick-firing grid resources. And so we're starting to see, on the margin, the battery compete with the once-through gas turbine. I think eventually, depending on how that price trend goes, as you will notice, this is quite reactive to commodity inputs. You could find that competing further into merit over time as time goes on. It's already being dispatched. Needless to say, this is from California. The ISO is kind enough to give us this data on a 5-minute increment every day for as far back as they've got it. This is every Labor Day for the last 5 years. And this year, Labor Day was more than 3,000 megawatts dispatched at peak from the battery fleet in California. If you go back just a couple of years, the reason it's not really being dispatched is because it doesn't really exist. So this is a sign of how fast this is emerging as a resource that's available to the grid and creating, I would say, all kinds of opportunities that are already being addressed by plenty of smart people. But more importantly, I would say, I don't even know what the opportunity is going to be yet from this. And then there's another thing that's being built, another thing that potentially can follow those falling rocket cost curves that you see with wind and solar and batteries, and that is electrolyzers for producing hydrogen. Another story that is very similar to those of you with experience in the solar market. It has a significant lopsided Asia-Pacific nature to it. This is not particularly surprising, I think, given the strong policy and the strong manufacturing capability, in particular in China, that is there for this. But regardless, it's a great big new potential source of demand for green electrons. Of course, you can operate it on anything you want, but the general zeitgeist for this is build the thing and then run it with clean power so that you're producing zero carbon hydrogen. But this is, again, something we'll expect to see going and going. The cost curves are beginning to come to light in a way that we can analyze and get a look at. There is now becoming an increasingly deep body of research about what that could look like on the grid. I'm not going to get too deep into hydrogen because, if I'm honest, it's actually beyond my capability to kind of do the full market sketch for it because it's incredibly complex. It's got many more variables to it than I think pure electricity does. But it also means that it's got a lot of opportunity and a lot of things to be figured out. We've got more than 500 electric vehicle models now on the road, including, I don't even put the label on it, but a couple of fuel cells. They sort of count. Important in this to note is that actually we're seeing on a model basis the kind of prevalence of pure electrics over the plug-in hybrid. This is interesting. From a manufacturer's perspective, plug-in hybrids is kind of the worst of both worlds. You still have to run a conventional powertrain, and you have to run an electric drivetrain as well, and you have to have a battery. So you're starting to see this sort of impetus leaning towards pure electric as a bigger part of the fleet. On a sales basis, quite a bit. Last year, electric vehicles, would include plug-in hybrids, that they're a small amount of the share, was about 10% of global sales in the fourth quarter of 2021. We're expecting about 10.6 billion sold globally this year. You can see again, it's overweight a couple of key markets. The North America, and in particular the United States, are really laggards in this compared to other markets. But importantly, really, this is growing pretty much everywhere. There's another thing to note about this, and it's hard to see. I don't show it because it's very hard to see in a chart, but it's important to know, is that the global new passenger vehicle fleet sales, rather, not fleet, peaked in 2017 at about 85 million. And it's been declining ever since. And electric vehicles are growing. And what that means is that actually, it's not just that EVs are a growth market, they are the growth market. So more than 100% of all growth in passenger vehicle sales for the last 5 years has been electric. And if you look at the way that manufacturers are approaching this, you can reserve judgment on whether or not you think it's the right goal for them to be stating. But they're sort of all in from a CapEx and a tooling perspective. And it will be very hard to unring that bell once it has been rung. So there are definitely a lot of short-term and supply chain related issues that could come up and impair or complicate this transition to EVs. But from the manufacturer's perspective, this is where most of the R&D is going, obviously, but it's also where most of the CapEx and tooling is going. And we're also getting a significant erosion, even though it is of a very high base, of oil demand in transport coming from electric vehicles. What's neat about this is almost all of it is coming from 2- and 3-wheel vehicles in Asia. So it's mostly coming from rickshaws and tuk-tuks and bikes. But if you think that our oil market is in a tight supply-demand balance right now, imagine if we had this additional almost 2 million barrels a day of demand to be accounted for, given our current supply condition. So again, it's hard to see these things when they're eroding a top line that still looks pretty stable. At the moment, this removal of oil demand is simply keeping it from growing faster. But as you carry this forward, you're eventually going to see this begin to materially erode actual road transport fuel demand. And that has many, many implications. I can leave it up to you to just to imagine if you want. I alluded earlier to San Francisco's vacancy rate, but if you want to get a little nearer to home, like right up to the really high frequency stuff, we're still not really back to work. And I mention this because I think that this is super important for many reasons. And I varied on this over time, and depending maybe on my mood. Like one, early on in the moment, I was thinking about this very much from an energy perspective. What are we to do with these buildings that are half empty, but you still got to run like they're full? I think about it now a lot more about how the workforce that we're all building is functioning in a world where only half of them are in the office all of the time. And in particular, the younger end of the workforce. I will be candid about this. I think I was way too sanguine about working from home early on because I'd already been around for 15 years with the team that I helped build. It's pretty easy for me to say that I can do anything from anywhere, but it's less so and for my newer colleagues who had just joined. And in fact, it was the associate and the junior associate, and the analyst level in my group that was the first to get back to the office. I was the first to get back and collaborate and work in teams and learn organically from each other. We got inflation, okay? Like this is a real thing. Again, another thing I will confess that I was probably too sanguine about early on. But it's not just here in the US, it's in the Eurozone. Intriguingly, an inversion of typical trend is that there's higher inflation here and in Europe than there is in India. This is not something that we're typically used to. And I think that our policy responses to it are proving to be complex. I don't want to say messy because I think people are very much doing their best. I think that we have very little idea where exactly we're going to land. The markets are very reactive to each new print in personal consumption expenditure. and core CPI. And it's just something that we in this room are really all takers on. And that's unusual, especially if we've spent the last 10 years in a near zero interest rate environment that was incredibly enabling in terms of building new things. And for that matter, incredibly enabling for people who were investing at the very early end of technology spectrums as well. The dollar is super strong. I'm sure that everybody in this room has noticed that. Great if you're buying in dollars. It really sucks if dollars are not your natural currency. But the dollar is the strongest that it's been in almost 20 years. And that has implications all the way through trade balances, towards pricing for imports, for oil prices. But again, this is something that we really don't have much control over in this room. And it's just something that we have to react to and incorporate into business in a way that we haven't had to do in a very dramatic way since really most of the financial crisis. And supply chains are still very, very tight. This is a chart from the Fed, and then look at this on a standard deviation basis. So we were 4 standard deviations above the mean in 2021, like the worst of our sort of pandemic responses. And we're definitely doing better now than we were in terms of supply chain pressure, but definitely not anything like free and open trade amongst nations, and especially not in a lot of the things for energy, goods, and services that are so key. We live in a gas island here in the United States, as I'm sure any of you coming from Europe may have noticed, but it's really extraordinary how little impact on a global basis the US has had from moves in gas markets. Look at Henry Hub and Brent, which would be what you're going to convert if you're going to do it to LNG. It is still much higher than prices used to be, and considerably lower than where any price on a dollars per MMBTU basis were anywhere in Europe. I mean, those are some exceptional spikes. Those give you forward something like 300 euro per contract, which is just shocking. And this, by the way, is for 1 month. But we also see things like this, which is year ahead baseload power at $1,200 a megawatt hour, is just absolutely punishing. I mean, it is a sign of markets that are very much stretched and quite possibly capable of breaking, depending upon variables that, yet again, we don't really have any control over. And those variables are things as simple as what's happening with the big land war in Europe to the weather. And so we find ourselves at moments where I think trying to manage all of these things is both very difficult, but very, very essential as well. So that's today. That's the long today from the 1750s up to now. But David and colleagues were kind enough to sort of ask me what comes next. And so if I wanted to say what comes next, I think we need to start bucketing where we are today a little bit better. So the first is that that renewable energy and energy transition that I showed you is good, but I think it's more important to decompose it into areas and new eras, as I've called it. So we're all probably familiar, and many of us may have come up through the world of building a lot of wind and solar, and that's great. It's about $400 billion a year enterprise on a run rate. Electrified transport and storage is really got a bullet. It's going to be probably more investment per year than you see coming out of renewable energy in just a couple of years. But if I think about this last bucket, which I would call like the real deep energy transition stuff, getting out of just electrons and getting out of just that particular part of the oil barrel that goes to road transport, and you start to see that we have, in one sense, some investment. We get about $100 billion a year worth of investment in decarbonizing the rest of it. But we also have a need to move all of these things up. So just very rough math, let's imagine that we're going to get this to $3 trillion from $750 billion. We need about 2.5 times more renewables. We need about 3.3 times more stuff happening in transport, and we need just under 10 times more investment happening in materials, in CCS and in hydrogen, in nuclear and electrified heat. There's a huge surface here that needs to be addressed. And again, it is being addressed, but like moving that last third there is going to be really difficult, but again, a really good opportunity. The other thing is that, and I've alluded to this already, we're entering a period of Let's call it variability if we want to be positive, not just volatility. I showed you that list of all of the battery dispatches on Labor Day in California. But this is what the whole mix looked like on Labor Day this year. And the important thing to note is that batteries were not only peaking above 3,000 megawatts at peak, it was also more than the nuclear fleet, well, the one nuclear plant still operating in California, was able to produce. But it's the intensely reactive bit. It's the part that's operating economically, quick firing on very short-term signals. Solar and wind are doing what they're supposed to do. Imports are doing what they're supposed to do. But you have to sort of get with this notion that we're going to have more variability. And there's a couple of other ways to look at that. The first is that we're at a moment in California right now where two things are true at once. You can have the minimum load down to almost nothing. In fact, earlier this year, renewables were 99.87% of load, very briefly, earlier this year in the spring. But at the same time, your ramp rate is now 17.8 gigawatts in 3 hours. And so you have one thing that you have to manage and another thing that you have to do. And these are way outside of the parameters that people were thinking about 7 years ago when this data series from the California ISO begins. And the final element of that is that you've got to figure out what to do about this. So California's response right now, even with all those batteries, to its spring minimum load incidences is to shed about 600 gigawatt hours a month worth of solar. Now, it's from a sort of classical perspective, this is terrible. We're just sort of doing nothing with things that have been generated, more importantly, have been generated with no emissions. But I would like to think about what is a smart entrepreneur going to do with this? What industry, what business, what enterprise is looking at this and saying, I can get 600 gigawatt hours of power for free in this month. What am I going to do with it? And the answer isn't just mining Bitcoin. When I put that on, when I do mention this to people, it's inevitably profiles with laser eye pictures that tell me we can mine Bitcoin. It's not just Bitcoin. There will be other things. But most importantly, I don't think that we necessarily know what they are yet. There probably have to be people who approach this from a new principle of not, oh my God, we have to manage this curtailment, but I have this stuff for free. What am I going to do with it? The other one is we've got to get deeper into primary energy management, not just electricity. I've showed versions of this, and I mentioned earlier that there are certain economies where that top line is eroding. Well, the United States is certainly one of them. Our share of non-fossil fuels in our primary energy mix is about what it was at the turn of the 20th century. You will notice that our fossil fuels, again, this is sort of a recurring theme of the year, around 2005, 2007 peak, and all of the growth beyond that is happening from renewable sources where nuclear, fortunately, remains fairly stable. But you're starting to see electricity erode its way into this. But the real challenge is that it can't get into the things that are within chemistry problems and not just electrical engineering things. So we need to figure out what we're going to do to massively ramp up all that's happening in the world of electricity where we know things work. Interject that, if we will, into these systems that are traditionally much more thermal or purely chemical, and figure out how best to change the shape completely. Find that our primary energy demand continues to drop, within that fossil fuels erode, and then on top of that, renewable power just grows and grows. And then if we step it back out of the United States, the reason this is important is that we can think of these individual sectors that are hard to abate as themselves a country-sized problem. So chemicals and petrochemicals are about 3.1 gigatons of emissions. They're 6.3% of global greenhouse gas emissions. They're also the equivalent of India and Germany on their own. Iron and steel is India and Australia. Cement is Japan and Australia. Airlines and ships are more or less a Japan each worth of global greenhouse emissions that need to be addressed. And electricity can do part of this, right? And hopefully some novel science can do part of the rest. But there's a huge opportunity surface that has to be addressed here. And I find it useful sometimes to look at it not just in this sort of abstraction of a big emissions number, but in terms of if you were going to decarbonize India and Australia together, how big of an opportunity would that be? And we've got some ideas on this. One of the most astonishing things to me, as somebody still within an analyst team, is that we now are able to do what I always thought were kind of like goofy science experiment kind of analyses, to think about how you might actually get zero carbon steel production. And not only that, there are industrial companies that are actually interested in this. There are consortia that are active in looking to achieve this. So the sort of lens through which we think things are possible has widened significantly. And this is very refreshing, but it's also a timeline that is well beyond most of the timelines that we're familiar with working in. It's now to 2050. It's 5 or 6 business cycles. Some of us will still be working by the time this is achieved. Some of us may not be. Also, finally, I think we need to have some really innovative approaches in terms of partnership, in terms of corporate priority, in terms of strategy. I just want to highlight a couple of them. Like I'm thinking here of, in the marine sector, a big consortium to think about green marine fuels and also think about ammonia bunkering, using some real deep science to look at climate change itself and address it from the principles that artificial intelligence might use to address it rather than what we have established today. Looking at new markets for trading. On the policy side, we need to be more innovative too. I'm sure everybody here noticed how quickly the US moved to essentially change the nature of the Strategic Petroleum Reserve, to use it not just as something for physical supply disruption, but for actually supporting markets and setting a collar more or less on prices. The great thing about this is that this emerged as a white paper from Employ America earlier this year and became White House and Treasury policy by a few months ago, and is now something wherein the US government is a participant in the oil market. Now, the SPR has always been participating. It's just a matter of how is it treating it deliberately. And this is going to be really important as we get to a future where there's a lot of short-term volatility in hydrocarbon markets. As demand falls, we will have these short but very intense supply-demand gaps. And that, I think, is a sort of new reality that the SPR and things like it can play in. I gotta love this one. Anybody here remember Jim Barksdale, Netscape? I almost said Netflix, which is showing my age, but Jim Barksdale was on a road show for Netscape, and somebody asked him what their strategy for making money was, and he said, "There's only 2 ways I know to make money, bundling or unbundling." And I raise that here because many of you have probably been through a couple of corporate life cycles of saying that, like, this large, stodgy business is not that efficient. We gotta unbundle it so that we can go out there, create new efficiencies, create new opportunities. And then a few years later, when that didn't work, they were like, you know what? This is all over the place. We got competing priorities. Nobody knows how to make any money. We got to put it back together again. And I say that facetiously, but I think, honestly, we're going to see this sort of play out like an accordion over the course of the next couple of decades. And depending on the market, depending on the maturity of that market and the technologies in that market, we're going to see much more suppleness in terms of how people think of what is bundled up for economic advantage and what is unbundled. And then finally, just investing a whole lot more. So my colleagues run this analysis every year. We can sort of spitball the middle of it, but if we want to get to net zero emissions by the middle of the century, we're somewhere in the range of $100 to $150 trillion of total investment. There's a lot of ways to do that. These scenarios involve doing a ton of clean energy. Some of them involve doing a lot of nuclear, which also gets used for thermal and chemical processes, not just for power itself. And we also have scenarios in which there's quite a lot of CCS. What's important about all of this is that these are all a policy choice. I think the business as usual, if we were to draw one for the future, is going to be this green path. We're just going to build a lot more renewable power. We're going to use that insofar as possible in sectors outside of the power sector to help decarbonize. Voila. Now, doing that this way would actually be very expensive in terms of CapEx, or rather, it would involve a lot of money. But it also involves choices. And I think that the future is going to be a series of choices that we have to negotiate with ourselves. Like, what is our priority? Is it energy security? And if so, with what lens on that energy security? Is the lens on security about security of supply, or is it security of supply chains? Is it about being domestic, or is it about being diverse? Is it about being technologically robust to disruptions, or is it about having multiple options in play at once? Dave, you asked me for sort of a call to action, if I was going to offer one for the room. And my call to action would be to first expect that we have volatility, small v, neutral term volatility, to a great degree in coming decades. Part of that are things that will be outside of our control. Some of them will be inherent in the nature of these very low cost, highly distributed, zero emissions technologies that are being deployed. And then the call is to embrace that and to think about what you do, not just to manage it to avoid disruption, but to use it in beneficial ways. You know, you're facing a market in which one grid operator's curtailment is another emerging startup's free electricity to do something with. And so to think about this volatility that's coming as something that is first going to be there. It'll be inherent, I think, in the system for most of our working lives. But secondly, that it is a huge opportunity surface for doing things that are new. And with that, I think I'm right on time. Thank you, everybody, and thank you for bearing with my own giant slides that clogged up the machine. So, thank you.